win. Probably.
I was told this was yours.
It's not mine.
Okay.
Let's put that
Goodbye.
Jake.
Have a good class.
No.
You will not. I'll still try.
What was I trying? Oh, yeah. TV.
I told you.
That's why I needed to walk in this direction.
That's so real.
Like you're walking into a room going,
We're
why
so
am I
good.
here? Instantly forget.
Sometimes I think, and then I forget. It's like one of the best sounds on, I'm sure it probably is actually from TikTok, I don't know. Oh, but the best sounds on Instagram. Because I don't have a TikTok. I only have Instagram Reels. So TikTok's 2 weeks later.
There you go.
That sounds stupid.
Good.
Crazy.
Good for you.
I had a person try to scam me today.
Fun.
Usually I talk to them for a while, so and waste their time.
Yeah.
But I told this one
You scammed
that I
them.
didn't want to do that.
Oh, you missed it.
Listen, Marcus. All right.
Alright.
Gemma, you sound grumpy about life today. Are you grumpy about life today?
No. Yes.
No. Or am I just projecting?
I think you're projecting. At least not for me.
Oh, actually, I have good audio, but I'm still using crappy audio. We should use the right audio.
No.
Boom. Oops. There we go. Now, there's good audio.
Better not to.
Okay.
Okay.
Number 2 is wherever number 2 is. There it is. Oh, there it was. There it is. Number 2 looks like that. What numbers did we do? 2 through what?
2 through 20 evens omitting 8.
Okay. Number 4 looks like that. Number 6 looks like that one. Insufficient storage space. I don't understand that notification. Are there televisions that have storage space, and what is it trying to store?
Where is that?
Is it your phone?
Yeah, that's what I was gonna say.
Like,
No, it's not my phone.
where?
It's the TV.
It just wants attention.
Number 10,
8. 10. No.
we omitted 8. Number 10 looks like that, and you can also see 12.
12.
Mm-hmm. 14 and 16 are there. You notice the domain is always all real numbers. And the range is the horizontal asymptote to wherever, in positive or negative infinity. And 18 is right there. (20a) is about 207. And 20b is that one right there. Great. What questions do we have?
2.
Okay. Huh? Machine. What are you doing? Yeah. Why is it empty?
Well, my homework's over here, but I do the problem on the surface.
That's, I see. That's good.
14.
Well, we're gonna do number 2 because that's what was asked about already.
Go.
I'm just trying to turn the stupid TV off. I don't know why that one remote worked once.
Are you sure?
Don't you, that's what they always say on these scams. Don't you remember me? No, we've never met.
I went to school with you.
I told this person that no, you don't know me, and I'm about 99.9% sure that you are a scammer. And they said, okay, whatever you think, and then they left. That's so wild.
I think I went to school with you in second grade.
Number 2. What questions should we ask ourselves? No, that's not one of the questions we should be asking ourselves. He said what to do, which was funny, but was not the right answer.
X and Y, T, Y.
No. That's not a question. That's a picture. So we're new to this. So it's not totally shocking or frustrating or anything else that y'all are just staring blankly into space.
We need to, like, I forget, like, how to actually say it, but, like, we need to make a table relating.
Okay, we're gonna do that, but that's not the question we're trying to ask. Y'all are all around things. Well, you were just funny, but we need to ask ourselves what the parent function looks like. We know at this point 3 parent functions. We know the linear parent function, we know exponential growth, and we know exponential decay. Those are 3 parent functions that we know. Which one fits this? Exponential growth. How do I know exponential growth fits this one? Nope. The parent function is y equals b to the x.
There's only one real number. There's only one real number because there's y equals b to the x, and there's also y equals ab to the x.
Yeah, I left off the a part because it's not relevant for growth and decay. But if you want to put a on there for that, that's fine. When I'm looking at these numbers, which one tells me whether it's growth or decay? Look at your notes.
B.
D. What am I looking at as far as B is concerned? B is positive 5. Yeah? But when we do negative 2 squared, only the 2 is squared. It's in parentheses for the whole thing to be squared, right? B is 5, positive 5. How do I know it's growth? Because it's positive 5. What am I seeing? Look at your notes. B is bigger than 1. So I know that this is the parent function I'm talking about. So the first question is, what parent function am I looking at? We figured that out. What's my next question that I need to think about even before starting to make the table? We want to ask these questions first because these questions will help inform what we need to do. Kinda. No.
Dilation, reflection.
So you're on it. So how does our graph change the parent function? It does have something. What does it have? What in this equation changes the equation from the parent function? No, y is definitely in the parent function. The x is in the parent function. Yes, the negative. I've said this before, lots before. And I'm going to expand on this statement so that hopefully in the future this won't have to be said eventually. When you're in class, as well as when you're at home doing homework, you have to mentally engage with the material. You have to check in with yourself and be like, do I understand what's being said? Right? And if you stroke off for a second, and you're in your brain, it turns into an old man brain for a minute, and it disappears from you. And when you come back and you're confused where you are, you've got to check in. Right? Because you have to understand what's happening. So, if you are used to just copying down what I write on the board, you're going to have to do better than that. Or else you're not going to learn new things. Okay? So, now that that's over with, the parent function of this is this. Y equals x. What does that look like if I graph that? If I told you to graph it right now, what does it look like? Straight line with what characteristics? What? True. That makes it a line. Yeah. That's not. These also go on forever. So, where is it? Like, what is the process to graph? Like, the instructions on the problem are graph. What would you do? Yeah, where are they? So we start at 0, 0, and then what do? Up 1 over 1. Great. We did it. We graphed it. How does this change the parent function?
Now it's up 1 up 2.
No. What?
You start at the y-intercept.
So the y-intercept, so this would be this same graph shifted up 4 units, yeah? Go up 4 and then count up 1 over 1, right? So it'd be this line, right? How does, and that's not the change, let's start to bring it back to this. So this is the parent function in black. That's the parent on this one. How does this change the parent function?
Now it's down 1.
Down 1 over 1, right? So it took it and it flipped it over, right? That doesn't work. It took this graph and it flipped it over the x-axis. I'm going to do it like this because magnets, but it turned it into this, right? So it reflected it, right? So a negative in front of the parent function reflects it, yeah? Same thing here. What is this going to do? Reflect it, right? So instead of being like this, it's going to be like this, right? Why is it helpful, useful, a good idea
to go through that mental process before you start throwing tables and graphs and all the things. Okay, so you'll understand it. Sure, that's not even all of the answer to that question. So what? So you'll know what to expect when you're going to draw it, and you'll also know what numbers are useful to plug in, right? Because this graph, as we go more and I didn't draw that right at all. It would be right here is where the axis will be. As we get more and more negative, this graph is going to do what?
Decline.
It's actually going to go decline, but negatively, right? It's going to get closer and closer to zero, and it's never going to touch, right? That's what it's going to do. So we put again a bunch of negative numbers, then we're going to get 0 point tiny numbers and 0 point tiny numbers and more 0 point tiny numbers, right? So, and we also know if we put very big positive numbers, we're going to get giant negative numbers, right? So we want some numbers in here. Is this making sense?
Yes.
Good. So now we can head to the two suggested paths. Now that we know what we're wanting to do, let's do that. Okay, so what numbers do we want to put in our chart? Okay, so y'all are just you didn't hear anything I just said, or you didn't stop to think about what it meant. We wouldn't necessarily want to do -2, -1, 0, 1, 2, like we always do, because that's not going to tell us very much, right? We might want one negative number and then more positive numbers, right? So what would be useful numbers to chuck in there? How about -1? The further we go over here, closer, let's keep it small, yeah? 0 is a great idea. And then 1, 2, 3, sure, why not? And that's plenty. Not necessarily, it depends on what all changes. Whether it's growth or decay, or whether it's whatever. Like, if it was decay, then we would want more negative numbers probably, right? Right? Okay, so what is 5 to the -1? Five to the -1 is not -5. What it is 1/5, because that's what the negatives do. It makes it change levels, and then -1/5 is -1/5, right? What's 5 to the 0? 1. What's -1? -1. 5 to the first is what? 5, and then -5. 5 squared. And then -25. So we're already giant, because this one's going to be what? -125? Right? So then, plot what you can plot. -1, and here, we're already way up there, right? And there. And then by the time we get to 1, we're at -1, 2, 3, 4, 5. So then you connect the dots.
So how do you know, with the first part where it's the first point was where it started,
You don't, okay, that's a useful question. You don't graph this like you would graph a line. You don't like start at the y-intercept and then count a slope. There is actually, but you won't learn about it till calculus if you ever even take calculus. But there's not really an equivalent idea of like counting a slope, right? You know what the overall shape is supposed to look like. You get some points, and then you connect them to where it's going to look like the overall shape, where it's going to be like a curve. Yeah. Which is another reason to go through this process, because you know it's going to look like this. And if you didn't know that, then you might try to connect these some way weird, like where it goes around like that or something, right? We just put these 3 dots on there, but we know the overall shape is supposed to be this shape, and so we connect them in this shape. What? Right. Yes. Yeah. Go ahead and close the asymptote, and then the whichever, whether it's growth or decay, the other end is going to go up or down if it's negative, right? I put a 1 right there.
But like how, like point-wise, how?
This is what you okay. This is what you were trying to ask the other day, and clearly it didn't. Me explaining it didn't work last time. So let's see if we can get there today. Okay, so we put a 1 right there. This is why I feel like we're running in circles in this conversation, because I don't understand where you're confused.
Where'd you get the points from?
No, you just choose it.
Where did I get the X numbers from?
Yeah, so you just do X. You just use X.
Yeah, and then you solve for Y by substituting them in. If I put a 1 in for X, and then I simplify this, we get -5. Y equals -5. And then I put the -5 right there. Okay. These are points. This is a point. If we were to write it by itself as a point, it would look like this. How do I graph that? Yeah, I go over 1 on the X and then down 5, and I put a dot there. How do I graph this point? The one that would look, if I wrote it just as a point, how would I graph that point? Yeah, I would stay in the middle and go down 1. And so I put that dot there. Does that make sense? Okay, I'm really confused where you're confused. Let me draw this again and go uber slow and see if we can figure out where you're confused. No, you don't know. You can think, but let's give a shot here. Okay. All of these are dots. All of these are points. Yes? Okay. Where is this one? Where, if I'm going to put a dot over here, where am I going to put the dot? Which one of these is X and which one of these is Y? This right here. Which one of these is X and which one is Y? Okay, this is Y, so this is up and down. Means that one's got to be X. Process of elimination, right? So how do I plot this point right here? Where am I going to go in order to find where that dot is? If I wrote this as a point, it would look like this. If I wrote that as a singular point by itself, so is this X or Y? X. What about this one? Y. This whole number, this 1/5 number. Which direction am I going to go for this? Left or right is what I'm asking. Left 1, and then I'm going to go which direction for this one? This is not a slope. This has not become a slope. This is a fraction. So I'm going to go down 1/5. Let me Well, okay. Okay. If I have a number line and I have it drawn like this, and I tell you to put a dot at 1/5, where would the dot be? Yeah, it'd be like right here, yeah? Same thing. So we're going to go to the left, and then we're going to go down 1/5. So a little bit. So we've got -1. So we're going to go -1 and then down 1/5. Actually, that's even over here, right? Down 1, left 1, over, yeah, no, that's right, 1/5, yeah. So close to 0, right? That's that dot. So that's this one, right? Where am I going to go to put that dot?
Down.
Yeah, so I'm going to put another dot right there, right? Where am I going to put the next dot? Okay, down 1 over 5. So I'm going to put another dot here. The other two dots are way the heck down here, so we're not going to worry about graphing those. And we know that it's supposed to look kind of like this, right? You understand where that's coming? That, like how we know that, or not? Or do we need to talk through that part? Are you sure? Okay. So since we know it's supposed to look like that, we connect the dots in a way where it looks like that. So it's going to curve that way. We put arrows on it because it's going to keep on going. Does that help? Does that make sense? Put it on your paper. Put it on your paper. Are you still confused about part of it, or you think you got it? All right. Any other questions on this problem?
Don't we have to do
The domain and range? Yeah, we do. We're asking what the domain is. What is domain? What does that word mean? Yeah, it's what X can be, right? So, X is up and down or left and right? Left and right. So, does our graph ever stop going left? No. Does our graph ever stop going right? It doesn't. It's just going slower to the right. It's going there, it's just going a lot slower. If this floor went to infinity, then the graph would go to infinity that way. Just slower than that way. That way it's going there real quick, right?
The graph eventually reaches it.
No, because this is continuing to get bigger this way, and that's continuing to get bigger that way, so it's going to continue opening up. A circle is x squared plus y squared equals radius squared, but you won't learn about that this year. Okay, so the domain is all real numbers, yeah? It is on an exponential. It is always all real numbers. Not every kind of function it's all real numbers, but the range is not that. Okay? We always do these low to high, right? The lowest number to the highest number. So, range is up and down, right? So, does the graph ever stop going down? No. I said we always do it. We're not doing an interval notation. This isn't Algebra 2. What am I talking about? Does it ever stop going down? No. It doesn't ever stop going down, right? Does it ever stop going up?
No.
It does because of that fun word. What is in this graph that makes it not get somewhere? It's the A word, the asymptote. There's an asymptote. Where's the asymptote in this graph? At 0. So in this one, y is less than 0. Not less than or equal to, because it's going to get closer and closer to 0, but it's never going to quite get there. Does that make sense?
I'm gonna challenge myself to do that.
You what?
I'm gonna challenge myself to make it go to 0.
Well, you can't, because there's nothing you could put in here where this would ever be 0. Your calculator will lie to you and tell you it's 0, but it's a rounding error on your calculator's part. It will never get there.
So range is always y is less than 0?
No, because if the graph shifted up or down, then it would change. Yeah. Well, so like if the graph was, let's say the asymptote was at 3, and it was this graph, the same graph, but then it would be y is less than 3. But if it was not reflected, and it was like this, then it would be y is greater than 3 on that one.
So it's like that, you just start at.
The asymptote, yeah, or whatever it was.
Make it like x. Should make it like the x line.
Yeah, we do like to dot in the asymptote when it's not 0, because it's easier to graph it that way.
So if it's going down, it's less than. If it's going up, it's greater than.
Mm-hmm.
And wherever the asymptote.
Mm-hmm. What other questions do we have on this lesson?
So the domain that's here for domain is just all real numbers.
Mhm.
Not 20. Infinite.
20.
Yeah, can we do 4 next?
What is the next unit? Is it what I think it is, or do I need to like start skipping stuff? Yeah. Okay. Good. Good. Yeah, we're fine. We are just fine. I think. Is there anything else in this other than the, yeah. Yep. Okay. Good. We're good. We're in a good way. Because we have to get to factoring. Es muy importante. Okay. 20. Population of rabbits increases according to the model. P equals 200 times 2.5 to the 0.02 t, where t is the number of months and t equals 0 corresponds to January. Use this model to estimate the number of rabbits in March. So what would t be in March?
4.
Well, March is the 3rd month, so definitely not 4, but it's not 3 either. Why is it not 3 either? Read the problem again. Y'all read it to yourself so you can actually see. And why is March not 3 even though it's the 3rd month?
What page is it again? 427.
He was getting there.
I said 2. Come on.
You're so close.
I give up. I give up. Is it like by 200? Oh, because January's not 1, it's 0.
That's right. That's exactly right.
Yeah, so
It's because January is 0. Therefore, we need to use what for t? 2. What'd you did?
I put a 0 for some reason.
Which tells us that in this scenario, in January, there were 200 rabbits. But, okay, what should we do? Yeah, exponent. What do we need? We need to do something in the exponent. 0.02 times 2, yes. What is 0.02 times 2?
1.5.
Is it?
Yeah.
0.04. Now what? No, we don't, because order of operations, you don't do multiplication first. You exponent. So 2.5 to the 0.02 04, which is what?
Is 1.037331582.
Times 10 to the something.
Well,
Hmm? It's not 10 times 10 to the something? Wow, that's surprising. To the 04 to the... Oh yeah, no, that makes sense. That actually does make sense. Okay, so that times 200 is what? So we don't have point rabbits, so about what? About 207.
205.
1 rabbit.
207.5.
So about 208 then,
Yeah.
if we're rounding correctly.
Just wait, one day we'll have
Wait, is
point
that
rabbits.
correct?
Huh?
Is that correct? Oh, we're not supposed to. That's
And then part B says graph the function and name the p-intercept, describe what the p-intercept represents, and describe a reasonable domain and range for this situation. Okay,
Alright.
let's do that. What do you mean, aw? Didn't you want? Weren't you the one who asked about this one? Well, then why are you awing? Okay, so we're supposed to graph that thing. Which parent function is it?
Decay. I mean, it is.
Yeah, this no, it's not.
Where are we looking?
0.5 or the 2.5?
The 2.5, yeah, the 2.5, and we're trying to see see what about it.
It's
No.
It's exponential growth,
It is exponential growth. Why?
because b is bigger than 1.
Because b is greater than 1. 2.5 is bigger than 1. I don't know if y'all knew that, but shocker. 2.5 is greater than 1. So this is the parent function. How does our graph change the parent function? It does.
Is it? No, it's added, so it's not.
It stretches by 200,
That's great.
right? Because a is bigger than 1.
Kind
But it doesn't flip over, right?
Right.
It doesn't flip over or move left or right or up or down, right?
Gets bigger.
But how do you know if it? Never mind.
Ask it. What are you asking?
How do you know how do you do the 200 thing? Like stretch it by 200.
of yes. Now
Well,
count.
we're going to start putting numbers in a table and we'll get big numbers. Okay.
Not stretch, okay.
So, okay. What numbers make sense?
Over 100.
So we don't have to put fractions in there. We could if you want, but we don't need fractional months. Whole months makes sense. Now, in this problem, not in this function, like if this was just f of x equals that to the x and whatever else, it'd be a different story, right? But in this problem, let's talk about the reasonable domain and range first, right? Because we can put negative numbers in here and we get answers. We get function answers. There's nothing wrong with it. They're going to be littler and littler numbers, getting closer and closer to 0, and never getting there, right? But can we have negative months? No, time travel doesn't exist.
Yes.
Backwards time travel will never exist. Forward time travel already exists. I just traveled in time, like a whole minute.
Which you can slow down time travel, speed it up.
You cannot, but you can slow and speed up relative time, and only if you can travel near the speed of light, which that's not possible
Well,
yet.
just that.
Yes,
Not just
I was
that,
about to say
but
that.
if the sun,
That wouldn't change time.
getting the earth lighter or heavier.
That's not time.
I,
You talking about gravity?
Yeah, I read something. It's possible.
Gravity does affect time, which is why time shifts in near a black hole. Yes, that's true.
I hate time changing.
You hear time changing. So,
Time travel.
what is a reasonable domain for this? 0 to something. The high upper bound, you could say 12. You could say a infinity. You could say whatever. Like what population makes sense. Eventually, this model is going to break down, and it's going to because of death, right? So you could say rabbits live what, like 4 or 5 years, 3 years, something like that. And so you could say 36, right? Is a good amount of time. Life of a rabbit, right? So something like that, right? So that tells us a little bit what numbers we can put here, right? We don't want to put -5, right? We can put like 1. That makes sense. 3 because we just found it. That makes sense. And then how about half a year? And then how about a whole year, right? How does that sound? That sounds pretty reasonable. Then our graph, our picture, because we're going to include all of these. We're going to have to adjust our picture a little bit because we're going to get big numbers, right? But we will our graph will be a year's worth of population growth, right? Okay, so we put a 1 in there. What's 0.02 times 1? Wow. And then what's 2/5? What's 2.5 to the 0.02? He forgot his calculator.
1.0.
Why don't you pull it out then? Oh. Great. That times 200 is what?
203.69.
Oh, actually, this would be 11, and this would be 5. And this would be 2. Because January starts at 0. It's 200 and what? What'd you say?
203.69.
So 204. This one we already figured out was 208, right? After 5 months, so in April,
There's 2 bonus.
in April, let's do that. So we put a 5 in there. What's 5 times 0.0? No, I can't talk today. What is 0.02 times 5? Okay, great. Don't care about that. What is 0.02 times 5?
0.1.
Yeah, that's what I got. Oh, no, whatever.
What's 2.5 to 0.1 times 200?
219.
And then after a full year, put 11 there. What's 11 times 0.02?
0.22.
2.5 times to the 0.22. So,
Times about 2.
what?
100 times 200?
244.
Full 244.
Great. So, how is our graph going to look different than it typically does on this problem? So it's bigger numbers, that's true. That's one of the more obvious ones, yes. How else is it going to be different? Normally, we do this. We are not going to do that this time. So we're only going to do quadrant 1, right? Because that's what we're restricting our domain to. You do have to do it. And we're supposed to label this, label our axes. What is this axis? It is not X. There ain't no X up there.
T.
Yeah, what is T? What is T?
1, 2, 5, and
In words. Time in months, right?
10. Boom.
That was difficult. What is this axis?
That is the
Population of rabbits.
Population of rabbits.
Population of one.
You forgot this.
No, I don't.
Okay, we should just stop it.
Okay, bye. Go by 50. Count like a big ring right there. Count by 200.
Count by 50s.
That's easy.
What am I doing? How about we count by like fives,
What?
but starting at 200? How about we start at 200 and count by fives?
Crazy. I was
Once?
Twice.
No, stop. 210, 215, 220, 225, 30, 35, 40, 45, 50. Why did I do it like that? Why did I reject y'all's suggestion?
Because our suggestions sucked. Because it would be harder to graph.
Because, well, arguably it'd be easier to graph. But if we had counted by like hundreds or whatever, the graph is going to look pretty much like that. It's going to look like a flat line almost, right? But we changed our scale so we can see some growth, and it's going to look like something we look like. So there, and then we're going to go count by what here? 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, I never would have been able to do that without y'all.
We're so amazing.
So at 1, it's at 204.
Because it doesn't start at 0.
0 is right here. I already put the dot.
Oh yeah. Oh yeah. Whoa. Crazy guys.
And then at 2, it's at 208. And then at 1, 2, 3, 4, 5, it is at 219, which is 10, 20. So this is 220. So it's like right here-ish. Clearly that one's wonky. Something. I think my things are getting closer together. But it's going to look something like, well, I went crazy. It's going to look something like that, right?
Right. Cool.
Cool beans. Let's talk about the last lesson that we're going to cover in this chapter, which means there's going to be a test on Tuesday.
No. Oh.
Today we have a test.
Yeah, we have a test right now. Yeah. 10 minutes to take a test over exponential functions.
I can't go.
I quit.
7.5, right? 7.6. 7.6.
7.6, growth and decay. This is the equation for exponential growth. Actually, it is pretty easy. It is pretty easy. This particular lesson, if you take a cue from what the advice I give people in physics, it's pretty simple. So R, yeah. And that piece of advice is, all you have to do with these problems, because these are all word problems, all of them, is you have to write down your givens with the units, and then stick the things in the formula where they go, and then just do the math. That's easy, easy peasy. So we need to know what these letters are. Huh? That's a 1. There's always a 1. That is true. It's a constant. This is the amount after T years. A is the starting amount. One is 1. R is the rate of growth. It's usually given in percent, and you'd have to convert it to decimal, yes. And what do you think T is? We actually technically already said what it is. Time in years.
So to do a percent to decimal, you just divide by 100.
And actually, in this general one, it doesn't really actually have to be years.
Or you
But
just grab this handy tip.
that's actually not quite true.
0.1.
Easy peasy?
Yeah, sure.
Okay, let's do a problem. After I get a new black marker.
I'm done with the problem already.
Cause it's.
You're done. You are. You don't even know which problem we're doing.
Problem 1.
No.
Wait, so wouldn't it be? I just leave 1.
We are going to do guided practice 1 on page 430. And I am not going to waste our time writing the whole problem out, but I would, if I were you, write down the words I just said out loud so that you know where all this numbers and stuff came from when you're going and using your notes to study, because that is still a good idea. I know I told y'all that a long time ago, but using your notes to help you study is still a good idea.
Oh wait, where's the
Guided practice 1, page 430. Yeah. Smartphone apps. The number of applications in thousands that are on the market for smartphone can be represented, that's totally how you say that word, by y equals 320 times 1.22 to the t, where t is the number of years after 2012. Interpret the parameters of the equation. Make a prediction about the future number of applications on the market. Oh, I love problems like this. They're like super wide open. You can say whatever the heck you want to say, at least on the second part anyway. Okay, so it gives us the equation y equals 320 times 1.22 to the t. Okay, so it gives us that, and it tells us the number of applications by thousands that are on the market can be represented with that, where t is the number of years. Interpret the parameters of the equation. Okay, so what we're being asked is, what does this equation mean? What do the numbers mean in this situation? So we need to know if we can figure it out, how much they start. Was it money? What are we doing? No. How many applications that we started with in 2012? How fast are they growing? And we need to, and then it asks them to make a prediction about something in the future. So, how can we use our equation that I just gave you and those numbers to say words about it?
2012 into T.
2012 what? 2012, well, 2012 would be year 0. That would be where it started, right? Yeah, so T would be 0 in 2012. We're not doing any math right now. Right now, we're just trying to describe in words what's going on in this problem. So, what is the 320?
320 is the start amount.
Okay, great. So, we could write something like in 2012, there were about 320,000 apps. What rate are they growing according to this equation?
1.22.
No, but y'all are on the right track. No, the one is a constant, right? Because it's normally our generic equation is 1 plus r. So how could we find r by looking in here? Y'all are in the right place. It is 0.22, right? So 0.22 as a percent would be what? 22%. So the number of apps, yeah, is growing by 22% annually. I have two ends in it? I don't know.
I think so.
Maybe spelled like that.
I changed a little.
I think if I was writing this in my homework, I would have just given up and wrote yearly instead. Or Googled it, right? Yeah, hey Google, how do you spell annually? Annually is spelled. Okay, so that's the first part of the thing. And then it says, make a prediction about the future number of applications on the market. So, what would we do that? Yeah, it's time we're going to do math. What math are we going to do?
Plug in the number of years after 2012 into
Yeah, some number of years. How do we know what number of years to pick?
2025 minus, is that wrong?
It could be any.
It could be anything. But yeah, sure, if you want to go with like today, sure. That's just fine.
It can't just be like 2011. Like it can't be before.
Yeah, it definitely couldn't be because yeah, so how many years since 2012 is it today? Let's do that. Sounds great. 2025 minus 2012. Yeah, it's easy math. So 13, yeah, so let's say 13 years. So 1.22 to the 13th would be what? Well, yeah, you definitely can't do it in your head. I can't either. I could do 1 to the 13th in my head, because that would be 1. But the 0.22 part,
13.2.
great. Now multiply that times 320. 4,244. So 45. So you would write something like, by the year 2025, we can predict that there would probably be about 4,244
More apps.
thousand. So that would be actually what you would want to do is that many thousand. So how you would have to like
By 13.
what number is that?
4,200,000.
Yeah. So you would write something like, we can predict that there would be over 4 million apps by the year 2025. There certainly could be.
Wait, did it say for like certain
You
year
should
end?
rewrite your 3 and 13.
No, it's just smart.
Yeah, looks like
That's better.
Okay. All right. So I gave you this. I told you this formula existed. Oh, dang it. We're out of time. So I'm going to give you part of your homework, which means your test is going to be pushed back a day, but that's fine. We already figured out we're fine. We're fine. I told you we're fine.
Okay.
I'm going to give you a few homework. Your homework set is going to end up being short. Aren't you happy?
Yes.
2 through 10. Oh, 2 through 10 off.
Page 0434.
Page 433. Numbers 1 through 5 all.
1 through 5.
That's crazy.
That's crazy. Okay, go away.
Okay.
I replayed like 30 minutes ago.
It's okay.
You what?